All right, let's talk about where this goes next. And we've actually been using a word that we haven't touched on enough probably, but the idea of using graphs and tables when we're looking at limits, that's really allowing us, in fact, if you look at the title of this lesson, what it's allowing us to do is it's allowing us to estimate limit values. Right now we're looking at functions that play nice. And so when we look at maybe what the function is doing, where maybe it's going to 2.97 and then we say, hey, that's pretty much headed to 3. We are estimating when we do that. And it's important that you know that these are estimations. They're pretty good estimations, and they're problems that are worked out to make it where your estimations are in fact correct. But we are estimating limit values. And what we're going to transfer into now, we're going to transition into actually evaluating, which means we're going to be coming up with precise answers. And fortunately, we have some algebraic techniques that are going to allow us to do this. But we're actually going to evaluate, get definitively correct answers, not estimations, by evaluating limits analytically. And that's going to get us, we should say too, when we say analytically, what we're referencing here is these next couple of topics are going to be very algebra heavy. And if you're good at algebra, the next couple of topics might actually be the easiest way to evaluate a limit. If you struggle at algebra, it might be a struggle. But we're going to evaluate these limits algebraically to get exact evaluations for our limits. And in fact, it's really using these algebra techniques that are going to be very helpful when we start applying this concept of limit to our idea that we started off this course with, this idea of instantaneous rate of change. A lot of that is going to happen algebraically in the very near future.